the team from Intel will do the next presentation.
Ladies and gentlemen, good afternoon. We'll start our presentation this afternoon with a brief video. The first part of the video will acquaint you with Intel Corporation. The second segment will give some opening remarks by our Chief Executive Officer, Paul Otellini. I'll then present our business problem and the first two solutions that we implemented for that business problem. I'll then turn the stage over to our collaborator from the Management, Science, and Engineering Department at Stanford, Farial Erhoun, who will describe to you our breakthrough OR solution that we've been using in the business for the last 4 years to optimize capital investment decisions. She'll turn the stage over to our customer, Robert Bruck. Bob is a corporate vice president in Intel and general manager of the Technology and Manufacturing Engineering Group. This is the group that actually makes the capital investment decisions of the roughly $5 billion a year we spend on capital equipment. Bob will share with you the benefits that our suppliers have received from our breakthrough OR solution. And in addition, we'll walk you through a detailed application of our OR solution that recently saved us roughly $125 million in cost and allowed us to capture a $2.24 billion revenue upside. We'll close the presentation with some remarks from Andy Bryant. Andy is the chairman-elect of our board of directors. Previously, he was our chief financial officer and has been involved in this project over the many years that we've been working on it. It was actually under his direction that we did the 125 million cost savings and the 2.24 billion revenue. So with that, if we could roll the video.
Today, you will do something incredible. At Intel, we promise each and every day to make a better future possible. We believe that creating the world's most innovative technology will make today even better than yesterday, and that tomorrow will be better still. More people will have access to the world, and the world will have more access to them. Learning will become more infectious, and diseases less contagious. Playing fields will be leveled, and emerging economies will be built. Because the only thing more amazing than Intel technology is what people do with it. We imagine the world's next technological marvel. How people use it never ceases to astonish us. What we truly manufacture is progress. So we greet each day with the belief that what drives the world forward is innovation powered by human ingenuity. Because the world can't afford to sit idle, waiting. We are Intel, and we can't wait for tomorrow.
Hello, I'm Paul Otellini, CEO of Intel Corporation. What an honor it is to have been selected as a finalist for the Franz Edelman Award. The Franz Edelman Award recognizes something that has defined Intel's history: innovative operations research that drives continuous improvement. The advancements we have made in our manufacturing and supply chain operations have allowed us to deliver Intel innovations to hundreds of millions of people around the world. While we are proud of our history, we are also very familiar with the challenges of staying competitive and extending the benefits of computing to more people. To meet the needs of the future, Intel makes significant capital investments in the most advanced manufacturing equipment that require very long lead times. But we operate in a highly volatile market and have to make these capital decisions long before we know about the future demand for the products that the new equipment will eventually produce. This is a difficult decision process involving finance, manufacturing, supply chain, and operations. A team of leaders at Intel, in collaboration with researchers at Stanford, has met this challenge head-on through the application of operations research. Their insights have led to landmark advancements in optimizing capital investment decisions. The team has done nothing short of creating a win for all stakeholders, for Intel, for our equipment suppliers, and for everyone whose lives are enriched across the compute continuum. The details of this project are fascinating. It's our privilege to have the team leaders share their work with the Franz Edelman Award judges.
Intel was founded almost 44 years ago by Robert Noyce and Gordon Moore, and has been the world's largest semiconductor manufacturing company for the past 20 years, with 2011 revenues of $54 billion. Bob Noyce is recognized as the co-inventor of the integrated circuit, and that has become one of our core corporate strengths to build on that. We introduced the first microprocessor to the world in 1971, and since then we've developed a very broad product line. We now have something in excess of 5,000 SKUs in our catalog. And these are sold into a plethora of markets. On the lower right-hand side of the foil, you see our Atom product line that we sell into markets where the form factor has to be very small, smartphones, for example. In the lower left-hand corner, our Core line of products that are used in such things as desktop computers. And in the middle of the foil, our Xeon line of processors that power servers, running the internet, running the cloud. The upper right-hand corner is the world's first microprocessor that integrated 2.3 thousand transistors. The 8-core Xeon processor in the middle, one of our latest products, is built by integrating 2.3 billion transistors. But this success in the marketplace leads to the first issue in our business problem. As the market for our products increase in number and complexity, it becomes ever more difficult to forecast the highly uncertain and rapidly evolving demands. On the other hand, we have the work of Gordon Moore, recognized as having developed most of the processes that we use to make integrated circuits in high volume. Gordon showed us that we would be able to double the number of transistors on a given piece of silicon every 2 years, and we do this by continuously improving our manufacturing process, shrinking the transistors so that every new semiconductor product has higher number of features, higher speed, lower cost, lower power consumption with every manufacturing transition. What that looks like from a manufacturing standpoint is, of course, that every manufacturing process transition is a case study in capital investment decision making. You see 3 things here. You see, one, the 2-year cycle that Gordon predicted. Each of the new manufacturing processes takes 8 quarters to ramp up, and as soon as it's hit its peak, the next one starts. As soon as it's hit its peak, 2 years, 8 quarters later, the next one starts. The second thing, of course, is that improved manufacturing processes require improved manufacturing equipment, which explains the $5 billion that we expend on capital equipment each year. The third piece in this diagram is that these investments are really irreversible. The manufacturing equipment is built for Intel semiconductor processors, and we're usually ahead of everybody else in the processing technology. So the capital investments are irreversible. But this continuous improvement of manufacturing processes leads us to the second issue. Second issue is that as these manufacturing processes increase in complexity, so does the equipment it takes to manufacture the semiconductors. And with that, so grows the lead time of the equipment. We have to order the equipment longer and longer in advance. So interestingly enough, these two issues combined, they're really at the intersection of 2 of our corporate strengths. On one hand, our product design and product line. On the other hand, our manufacturing prowess. The business problem is at the intersection of the 2. As the time duration that we can accurately forecast shrinks, and as the horizon in which we have to order our manufacturing equipment expands, we have an obvious mismatch. Obviously, you'd like to have a really good demand forecast to order the right amount of capital equipment. So let me see if I can give you the ramification of that business problem in practice. I'll show you a particular example that's actually built from actual Intel data averaged over 4 previous manufacturing processes. The orange line shows you the demand forecast. The timeline is in quarters relative to the peak of the demand. And the blue line is the stair-step installation of capital equipment. Semiconductor factories are perhaps a little different than other kinds of factories. We generally install about 500 pieces of equipment to get the line running so we can begin to make product and sell it. And then every quarter for 7 or 8 or 9 quarters, add another 100 pieces of equipment to increase the capacity of the factory. So given an 8-quarter ramp and a 4-quarter lead time for ordering equipment, you see that the first equipment to start off the ramp, we have to order 12 quarters before the peak of the demand. The last equipment 4 quarters before the peak of the demand. Probably not surprising that trying to forecast 4 to 8 to 12 quarters into the future, the demand forecast error is pretty high. As reflected by the fact that, of course, when we have a demand forecast, we have a low confidence upper bound and a higher confidence lower bound. Now, this raises an interesting decision problem, and this was the decision problem was decided intuitively before we started to study the problem. On one hand, you can order equipment to the upper bound with a bad forecast and risk having $200 or $300 million of equipment sitting idle. On the other hand, you can order to the lower bound and risk leaving $2 or $3 billion of demand on the table. Faced with this interesting choice before we started to study the problem, obviously you would choose to be over capacity, and if you're risk averse like we were in this time period, you might find that you had over ordered to the point that you would have to spend $50 million in canceling orders and cancellation fees and still end up with $200 million in excess capacity. And when we started to study the problem, we actually noticed one interesting feature. And that interesting feature is that the demand forecast starts to get a lot better 2 quarters away from the peak of the demand. And so we thought, gee, if we could get a few pieces of equipment in 2 quarters, we could better manage that risk at the top, and we could still order equipment at the normal 4-quarter lead time with very little risk of having cancellation fees or being over capacity, and also very little risk of leaving demand on the table. And this looked like some sort of an option to us, but a different kind of an option. Not an option based on price, but an option based on lead time. So, obviously, senior management presented with the opportunity to try out a method that eliminates cancellation fees, that limits the amount of overcapacity we'll buy, that doesn't have very much risk of missing demand, authorized us to do a test on one type of equipment. We picked lithography for 3 reasons. Number 1, the lithography supplier was willing to participate with us in the test. Number 2, lithography equipment is in fact the most expensive equipment we put in the factory. The third factor was that we could exercise this, we could calculate this option idea without very sophisticated math. We wanted to start simply. And when we look at a piece of lithography equipment, we find that the first 6 months, the first 2 quarters in the 1-year build time, are occupied with a relatively low cost growing the lens. And the last 6 months is where the capital intensive stuff comes in to build the chassis to put the lens in. So the normal question of how much should the options cost was pretty straightforward. We bought some lenses, put them on the shelf. When we're ready to pull the trigger, build the chassis, we get the tool in 6 months. The second question was pretty easy as well. We're only dealing with one equipment type, so we could take the amount of uncertainty we had in the demand, divide it by the run rate of one tool, and figure out how many options we needed to buy. We finessed the third part about, well, when should you exercise the options, by convening a group of senior manufacturing personnel once a month who would have a look at the forecast and decide whether they wanted to exercise the option or not. Hence my term heuristic options here. So before we started our work, we used the intuitive method to make our capital investment decisions at some expense. We started in 2000 with the heuristic options that I've just described to you. We actually used them over 4 process transitions. We got very comfortable with the mechanism, with how to actually do this on a very simple one piece of equipment basis. But we realized about halfway through that, after the first 2 transitions, that in fact, if we were going to do this across multiple suppliers with multiple pieces of equipment, we needed a stronger solution. So we engaged Ferial. Another very important thing happened here. We did some benchmarking across various industries and found out that we really needed to decrease our order time, our equipment build time at the supplier, the transportation time to get the tools to us, the install time in the factory. So on top of our breakthrough OR solution, we've built a capital supply chain velocity program that Bob will tell you a little more about now. But at this point, I'll turn it over to Ferial, who will describe for you the breakthrough OR solution.
Thank you, Carl. So, as Carl mentioned, I'm going to walk you through our breakthrough OR methodology. I'm going to highlight the technical contributions of our team, and I'm going to summarize the recommendations that we have given to Intel management. When Carl and his team first contacted my research group about this project, needless to say, I was intrigued. Even though the problem looks very similar to some canonical operations research problems, such as capacity planning and forecasting, there were also some distinct characteristics of the problem, such as the combination of factors like the fact that capacity is built dynamically over time, and the fact that capacity decisions are irreversible. By the time that my research team was involved with the project, Intel has already started to experiment with the idea of dual sourcing for lithography machines, and we all agreed that that was a fruitful direction to further elaborate. Dual sourcing enables a cost-effective and flexible solution to Intel by combining the base and the flex modes, and it also enables Intel to learn demand and to adapt demand by shortening the decision time window, lengthening the decision time window. In addition, the options contracts allows an effective risk sharing between Intel and its suppliers, and especially this was very critical for us because from the very beginning we wanted to develop a win-win solution for Intel and its suppliers. We believe that this is a long-term must for the industry. My research group first approached the problem from the theoretical perspective, and we developed a dynamic programming approach to dual source capacity expansion problem. And we actually showed that dual source capacity expansion problem is categorically different and more complex than the well-known cousin of it, dual source capacity inventory problem. So given that result, which we published at EMSOM, we decided to just leave DP-based solution to aside, and we developed the DMAP framework. The framework combines various OR methodologies such as stochastic optimization and Monte Carlo simulation, and it includes various trade-offs. So the problem is complex because it has to handle trade-offs at 3 different levels of decision-making at Intel. At the strategic level, 3 to 5 years prior to the peak of the new process technology, Intel and the suppliers should engage in contract negotiation. At the tactical level, about 3 years prior to the peak, Intel basically reserves quantities from base and flex modes, given the contract terms. And at the execution level, during the ramp-up, basically at each period, Intel executes the options that they buy through the suppliers to build their capacity. Of course, this decision heavily depends on the forecast updates Intel receives over time. I'd like to emphasize that even though we developed DMAP in collaboration with Intel for Intel's problem, the use of the framework is not limited to Intel. Actually, this framework can guide other companies in other capital-intensive industries by using sophisticated OR technologies. Basically, this guidance is based on seamless combination of statistical forecasting with stochastic programming and Monte Carlo simulation. And the framework also has built-in sensitivity and scenario-based analysis capabilities. Despite the fact that the solution depends heavily on OR methodologies, it is quite intuitive and transparent to the end user as well. Let me explain the modules of DMAP briefly. The execution module provides Intel how much and when guidance for how much and when to basically procure capacity through the two supply modes. It does that by using stochastic optimization. We capture the evolution of demand and allow for timely decision making. Based on our extensive numerical analysis, we recommended Intel that flex mode has the highest value when either the forecasts or the demand realizations change considerably in time. Although intuitive, this recommendation was very different than the rule of thumb approaches Intel previously relied upon, and its value has been demonstrated during the recent economic crisis, and Bob will walk you through that case study shortly. DMAP's reservation module functions as a risk-sharing mechanism between Intel and its suppliers. By paying a reservation fee upfront and procuring options, Intel actually shares the risk with the supplier and in return enjoys the guaranteed delivery of the equipment. The optimal reservation quantities are determined by a combination of Monte Carlo simulation and stochastic optimization by considering various future demand scenarios. For each demand scenario, the reservation module calls the execution module to calculate the optimal order quantities and calculates the expected profit, and then we chose the quantities that maximize the expected profit over the planning horizon. After considering thousands of scenarios, basically we recommended Intel to reserve 8 to 14% of its capacity through the flex mode. This level of flexibility is enough for Intel to satisfy customer demand without overpurchasing costly capacity. And finally, the contract negotiation module helps Intel to determine the lead times for the two modes as well as the prices associated with those lead times. At this module, we basically do a sensitivity analysis. For each lead time and price combination, we run the reservation module and execution module. We calculated the expected profit. We calculate the variability of that profit, and then basically leave the decision to decision maker based on his objective function. He can just choose the alternative that leads to the best option. The strength of this part of the algorithm is it allows Intel to make strategic decisions by considering the tactical and operational level contingencies. As I have already mentioned, both the negotiation module and the reservation module actually uses execution module. So let me just briefly walk you through the execution module with a brief example. For our example, 4 quarters prior to the ramp-up, Intel actually receives the latest forecast for the next 6 quarters. Using this forecast information, we basically run the stochastic optimization and we calculate the optimal base and flex orders for the whole planning horizon. Once we just calculate the myopic optimal order quantities, we actually need to commit to only to the base, the first base order at this point. And the rest of the decisions can be postponed till later because Intel doesn't have to commit to those decisions at that point in time. Then, in the next period, we receive the updated demand information, and with that updated information, we just basically solve the stochastic optimization again, and we simply just commit to whatever we need to commit. We continue solving this problem in a rolling horizon fashion over and over again till the fourth period, at which time basically it's the last period for Intel to place a flex option, and that's when we just basically wrap the problem. In practice, we found this heuristic to be really performing well. It is efficient because it's forward-looking, and it also considers many different trade-offs. Eric, if we can progress the slides. Thank you. Next slide, please. So, DMAP actually enables Intel management to plan and operate an agile capacity supply chain by adapting effectively to changing demand conditions. It replaces heuristics and rule-of-thumb approaches with structured, OR-based, unbiased decision rules. And we originally developed DMAP at Stanford in collaboration with Intel. Then we transferred the decision support tool to Intel in 2 phases. In phase 1, we basically replicated the capabilities that we had at Stanford at Intel. But in phase 2, actually, we passed the ownership to Intel. Since then, the Intel researchers actually modified the code, and they add functionalities to the code, and now they are the owners, and they run the code at Intel's side. Before I turn the microphone over, I would actually like to thank our Intel partners for this wonderful collaboration on this high-impact and relevant problem. I'm very proud of the methodology that we have developed because it's not only in use at Intel for decision-making, but we also made academic contributions to several understudied problems. And also, I guided 5 PhD students throughout the process. With that final note, Bob, the stage is yours.
Thank you, Farrell. Is this working? Okay, all right, great. Before I begin, I wanted to preface by just stressing that this is not simply manufacturing. As Carl mentioned, it's expanded. It's over $6 billion a year of capital spending and rising at about 20% per generation. We also are the 3rd largest R&D spender in the world. And one of the problems with planning these technologies, we're introducing about 20% brand new technology at the beginning of each generation. And so our R&D labs are going through and actually haven't made a final decision on which technologies to insert while we're in the middle of this planning loop. Also, in terms of the technology, if you picture, if you will, 5 million three-dimensional structures on the head of a pin. That essentially is what we're able to build with this equipment technology. And as President Obama said when he toured our research facility recently, looking through a SEM, he said it's like magic. So it truly is like magic, and the magic is performed inside of this equipment, which has about a 10-year development horizon. So let me get into exactly how we executed with the plan. There are no overnight successes. This was the result of about 10 years of concerted effort. As Carl said, we really began in the lithography area. We used the theory of constraints. It's better to know where your constraint is and try to manage it. And lithography, in addition to being the largest expenditure area and the longest lead time, adds the most value in scaling. Some of the things have been talked about already. I'll cover a little bit. But during the heuristics period, the first few generations where we focused on lithography, it also taught us an awful lot about contracts and reservation and execution that set the stage for what Farrell talked about and we did later with the Stanford collaboration. It also resulted in us forming a really collaborative approach with the Intel supply chain partners. And that became very critical later, as it was not only vital to the success of this program, but it was tested recently with the Japan earthquake and tsunami. And the learning that had been done in the supply chain, you might have read across the press, but the automotive industry throughout the world was devastated. Their supply chains crippled out of Japan. Electronics industries. Intel had over 3,700 pieces of process equipment affected by the earthquake and missed 0 lost day outs of product revenue. And we think one of the important pieces, the CEOs of those companies come back and told us, is the work we did in re-engineering the supply chain 4 levels down created a very strong business continuity plan for them as well. So it really manifests itself in values in many ways. And then I'll talk about the base and flex modes and how we expanded that beyond litho to our critical 13 suppliers. When we engaged in those discussions, it was quite difficult. As you might have expect, that the first conversations were, hey, we'd love you to shrink your durations. And they said, well, great, I can give you more time to plan, just give me more money ahead of time and I'll set something on the shelf. Carl made the lenses and lithography sound a little bit easy. We're actually at the limits of optical lithography and limits of numerical apertures on lenses and mirror technology and laser technology. And so as you start to hit these physical limits, you need really an engineered solution, not just a time value of money or staging type solution. So as we worked through with them, we traveled, we put teams together, went to Japan, US, and Europe. It really went through to do a holistic re-engineering of their supply chains. And like I said, as many as 4 levels down to figure out where was their waste, where were wait times created, that sort of thing. Because when you create the options programs, you really want those to be optimized in terms of are you really buying value or not, and what decisions can be deferred and should be worth the investment to defer the decision, and what is just waste in the supply chain. So as we worked through that, by 2007, where we're now 7 years into this overnight success, at our annual supplier recognition event, went through this foil. It really showed some of the important benefits for the suppliers. And the first one, dealing with reliability, it deals with information quality as much as anything. And we modeled many years ago, but our customers giving us a forecast about 4 months before they want a shipment. And how often was that accurate at the point of shipment? It was wrong 97% of the time. So if you say, well, just get your forecast more reliable, that's not going to solve the problem. So it was being able to wait to pull the trigger, wait to make these decisions later was the key for success here. Also, in terms of being cheaper, it was really about asset utilization all up and down the chain. The equipment industry has gone in the 90s from about 8% of revenue reinvested back into research and development. Today, some of them are as much as 20% of their revenue gets reinvested into research and development. And the chip companies like Intel have done the same thing. So having assets, whether it's your cash or inventory or people, sitting around in your supply chain wasted is money that is not getting spent on research and development. And that was critical, we realized, to keeping the 2-year technology cadence moving. And also for them to return value to their shareholders. And then less waste. We actually, before the work with Stanford, had done work with Wharton, looking at applied materials, one of the largest equipment makers. And we found that all of the things that stood in the way of duration reduction were accounted for by churn and changing of plans. And if you looked at the arc of a long-term demand portfolio or profile, you found that it really didn't change that much looked at over the long term. It was changing by the month-to-month churn in the forecast. And that was causing them to waste money to try to anticipate and keep up with that volatility. And the last point of value is the industry for semiconductors is consolidating rapidly. There are only 5 chip makers left in the world who can afford leading-edge factories. They count for over 70% of the revenue. And the largest 2, Samsung and Intel, account for almost half of that. And the equipment industry is going through the same kind of consolidation. 10 companies represent 80% of all the capability that's out there. So we cannot afford just to shift cost or risk up and down the supply chain. We really had to form a holistic, truly collaborative effort to solve this problem for everybody. And what that has resulted in, we just held our supplier recognition event last week up in Santa Clara. Stock analysts and others report who is winning these quality awards at Intel because those partnerships endure long term. So let me get into some of the benefits quickly. I think we've talked about these a little bit, but the operations research breakthrough for 32 nanometers, which is the most advanced technology out there. Intel has now shipped 600 million units on 32 nanometer. Our competition really very little at all. And looking at the downturn that came, I'm going to go back in time a little bit to look at that and look at the upside benefits that we got. I'm going to click through this quickly because you've heard really about the tools themselves. So the base is a quarterly, 4-quarter look ahead, and this is the normal trend that we would have seen. And early in the technology, we didn't see any problems. But then Lehman Brothers collapsed, and the world banking system was in jeopardy. And this is what happened in the demand profile. And it mirrored the worst of the last three that we've seen, which was the blow-up of the dot-com and Y2K buildup. And you can see the duration of that downturn was very long indeed. So using our traditional intuitive model, we would have said, we got two choices here. We can pay $125 million and get out of our commitments and say that this is going to be a sustained downturn, or we can invest $600 million and risk that it's going to sit idle, wasted assets that could have been spent on something else. So we had flex, and by kicking in at that point, the base forecast for the next 2 quarters went on hold. That allowed us to flatten that demand curve, and we knew that we had the protection of flex if the demand was going to come back. And so it in effect, communicated to the supply community so they could manage their decommits, and they managed that out. Now, remarkably, with TARP, and in fact, the 70% of our revenue are exports to places like the BRIC countries that were still growing, we had a very strong snapback in demand. And really, it was almost unheard of. Intuitively, using the old models, it would have taken about a year to recover that capacity. But again, we had flex. So flex kicked in, and this is the curve you would have seen with about a 4-quarter recovery. And in fact, most of our competition went through this kind of an experience. Instead, we were able to pull back much more rapidly. And again, our supplier partners, having leaned out their supply chains, were able to do this for us with really not a waste of resources.
30 seconds to the video.
Okay. And so the gap between these areas is what the benefits were that we've talked about. We modeled these a couple different ways. The OR team came up with $2 billion plus. The finance team, working with confidential internal data, $2.24 billion. So a substantial, and I'm going to say that in 22 nanometers now we've embedded this in our next generation ramps, which are even more complex and even steeper. Feedback from the community. Our suppliers tell us the race goes to the swiftest, and the partnership with Intel is great. Our analysts are telling us Intel's taken this to a whole new level, and internally enabling the fastest ramp ever. Recognition internally, the Intel Equality Award is the highest recognition for an organization, and was granted based on the internal validation that we got. So in summary, heuristic solutions got us that far, but breakthroughs on OR got us to the next level. The impact and value is tremendous. The technical solutions really were novel, a combination of new breakthroughs and extension of other techniques. And the opportunities and challenges, we got over those in close collaboration with our supplier partners. And finally, it is very useful for anybody in a capital-intensive business. With that, I'm going to roll the video.
Hello, I'm Andy Bryant, Vice Chairman and Chairman-elect of the Board of Directors of Intel Corporation. We have been applying operations research at Intel for the past 25 years, adding business value across the company. The work started with individual factories, expanded across our manufacturing network, including upstream and downstream supply chains, and has moved into many facets of product and market planning. What you have seen today is one of Intel's most impactful OR applications to date. Having been Intel's Chief Financial Officer for almost 14 years, I've spent much of my career assessing business value. I believe that the application before you has multiple benefits. It is impactful historically, as it resulted in hundreds of millions of dollars of cost savings on the last few manufacturing process transitions, and over $2 billion in revenue upside during the recent economic anomaly. Also, it is impactful looking forward, as it will help us manage demand uncertainty every time we adjust our capacity. And we expect to be able to achieve more cost savings and capture more revenue upside in the future. And finally, it is impactful, enhancing win-win relationships with our equipment suppliers. More significant is the progress towards achieving our goal to create and extend computing technology to connect and enrich the lives of every person on Earth. Capital decisions, especially for leading-edge equipment, have always been critical to our industry's ability to make affordable technology available to more people. This OR application was a major component of Bob Breck's overall Capacity Supply Chain Velocity Program. For this Velocity Program, Bob's organization won Intel's most prestigious and competitive internal award, the 2011 Intel Quality Award, for aggressively pursuing continuous improvement and attaining high levels of excellence. Bob's organization and Intel are even further honored to have been selected as finalists for the 2012 Edelman Award. Thank you for selecting Intel. Now I'll turn the presentation back to the Intel Stanford team to answer any questions you may have.
Okay, let's thank the team.